All right. Hi, Ron. Welcome back to this. What we're looking at today is we're revising using the trig ratios to solve trig problems so that we can remind ourselves how sine, cos, and tan are actually used in practice before we start looking at all the new stuff regarding graphing the damn things. So, I have a right angle triangle behind me. You know it's a right angle triangle because of the lovely square thing here. And I've got myself a nice curved one here. So I'm going to label this one theta. And the name that we give to the angle that we care about is the reference angle. So we have ourselves a reference angle. And what I'm going to do is I'm going to tell you what the hypotenuse is. I'm going to tell you the hypotenuse is 8. And I'm going to then tell you that this length here is 5. So my question for you is, what is the reference angle in this case? So we need to figure out the reference angle. Someone in the chat has said sin. Correct. We need to use sin to help us solve this. So my question for you is, why did you get sin? O over H. All right. So, which one of these is the O and which one is the H? Five is O, that is correct. And the H is the 8. So, the sides of the triangle are O, H, and what's the one down the bottom there that we don't care about for this question? But it's good to know. Yeah, A. All right, so we have the opposite length because it is opposite to the reference angle. We have the adjacent length, which is adjacent to the angle. And then we have the hypotenuse. All right, the hypotenuse is always opposite the 90-degree angle. And in a right angle triangle, it is always the longest side. So if you're ever trying to solve for the hypotenuse and it's shorter than anything else, or you're solving for the other side and it's longer than the hypotenuse, you've probably made a mistake somewhere. So in this case, we want to figure out what the reference angle is. So to do that, I need to figure out, well, I have the angle, I have the opposite, and I have the hypotenuse. So that means that I need to set up a sine ratio with the angle involved. So, do that. So, sine theta equals O over H. And I'm going to substitute in the things I know. Well, I still don't know the reference angle, but I know that I have my answer there. Now, what this is going to mean is I need to do an inverse operation on it to solve it and get back to where I was. So, to figure out what theta is, I have to apply the opposite of a sine function, which is an inverse sine. So in this case here, sine of -1 sine theta equals sine minus 1 of 5 on 8. That means that theta is equal to inverse sine on that. So, for this, because it's revision, I want us thinking in degrees for now. So how many degrees is inverse sine 5 on 8? All right, can I get it to 2 decimal places, please? It's interesting, you said 38, and then I asked you for 2 decimal places, and you want 68. Well, wouldn't 68 round up to 39? Alright. Alright. So I've set up there solving trigonometry. There's another word that we use when we're talking about trigonometry. It begins with R. SOHCAHTOA are the trig, not the radians. Ratio, thank you. So they're called the trig ratios. And the reason why these are important is if I go back to the original problem and I say scale it up, and it's now, oh, I know, I can just get rid of the 5, get rid of the 8, and I can replace it with 16 and 10. If I do the same process and get the same and get to an answer, is the answer going to be any different? You go through that whole process again, replace the 5 with 10 and 8 with 16. Is the answer going to be any different?
No.
No. All right. When your opposite and your hypotenuse are in a 10 to 16 ratio or a 5 to 8, the degrees of that angle are going to be 38.68. All right, so no matter how big, so for example, I could then take this theta, put it in here, and instead start putting other numbers in here. So I could, for example, be like, well, okay, I have a hypotenuse of 19, and I don't know what the opposite is. I can use my knowledge of this to get the answer I need. So I know the angle because it's 38.68. Thank you, gents, to those who found it for me. I know the hypotenuse is 19, and I need to find the opposite. So I'm going to set up. I'm going to set up my ratio. So, sine of 38.68 equals the opposite, which is x, over the hypotenuse, which is 19. Now, if we were looking for a precise answer, what is sine of 36.86? We just calculated it before.
5/8.
It's 5/8. So I can now go, well, 5 over 8 is equal to x over 19. And by doing it this way, we've sort of undone the rounding error that possibly would have been introduced, because this was rounded to 2 decimal places for us. So now, how do I solve for this? Make x alone. How do I make x alone? Five plus? I think you meant to use a different symbol there, mate. No. Try again. 2 more to go. There we go. So, 5 times 19 over 8 equals x, which is 5 times 19 is 95, 95 over 8. Which is 11 and 7 over 8. I don't know what the decimal. Yeah, there you go. Thank you. 875. Now, I could only do this way because I knew where the 38.68 came from. If, for example, I didn't know where the reference angle came from and therefore could just easily make the substitution, I would actually need to use my calculator to solve it. So I would then have 38.68 equals x over 19, and then I'll just do 19 times and then that would be whatever my calculator gave me. And because it's using a rounded error or rounded number, I don't expect it to be 11.875. Someone on the calculator want to help me out with that one, please? (19 times sin 38.68). Alright. How many decimal places does that one go to, Murtaza? Yeah. So it comes out as 11.8744334. Obviously, because this is rounded, you end up with less information, which makes this a little bit wonky as well. So, I have a question for you. What if, using the information that I have here, I wanted to find the adjacent length? Which one would how should I go about finding the adjacent length? Does anyone else want to make a suggestion? Alright, well, someone has walked smack bang into my trap and said Pythagoras, no. Alright. why shouldn't we use Pythagoras to solve for the third length? So I obviously have a value for x. I have a value for x here. I got it in two different ways. All right. So I reckon if I use this over here where I knew the ratio is 5 to 8, I could probably get a pretty accurate answer. But this one down here, because it was rounded, means that I'm going to be using a rounded answer to find another length. There is also the question of, what if I made a mistake? What if my whole process of this was wrong? What if I completely derped and made a colossal mistake? I mean, unlikely, but still possible. All right, so you've redeemed yourself, Murtaza, because you've said cos. All right, when you are asked to find multiple things, you rely on and use as much of the original information presented to you as possible. That way, you don't introduce your mistakes into a problem that you're trying to solve, thereby creating more mistakes. So, look, I'm fairly confident that if I used 11.875 in Pythagoras with this, I would get the correct answer. No problem. Or the most accurate answer. But what I should be doing is finding out finding A is another way. So let's go. So 38.68 is 5 over 8. All right, so that's rounded. If this... So we've got this. I just thought of another way we could possibly solve it, but for now what we're going to do is we're just going to leave the reference angle as being that. So cos of 38.68 is going to be equal to the adjacent, which we don't know, over 19. So that means y is going to be equal to cos of 38.68 times by 19. Y is equal to what?
$10.56.
10.56. Does anyone else have a different answer? $10.56. Anyone have something other than 10.56? Oh, okay. Must be correct then. So we have a couple of different. So we've got all these values here. To prove a point. To prove a point. (19 squared minus 11.87443374 squared equals, or y squared equals (19 squared minus 11.875 squared). Someone want to help me out? Which one were you using, mate? Were you doing the one on the left or the one on the right?
I'm doing 19 squared minus 11.87.
11.875, thank you. So that means we've got y squared equals 222.93. Groovy. And so I now need the square root of that. $14.93. At least, I don't know where you got your number from, because I just put it into my calculator and I got something different.
Oh, I made a mistake.
Yeah, how about you correct that?
Mine was like 11.75.
See, 11.75, a little bit better. So I've got here y squared. So 19 squared minus 11.875 squared should be 219.84375, which means that y is equal to the square root of that. And it should come out as 14.83. 187 da 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 da. Da 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 da. And whoever did yeah, 10.57. this is awfully interesting here. So 19. So we've got 14.83 here. But what?
Sir, 19 times sine of 38.68 is something else. Is I think 15 point something. 19 times sine of 38.68 is 15.78. It's not 11, sir.
Do you know what someone's done? And they've completely bamboozled me too. What mode's your calculator in?
Yeah, I was wondering.
Yeah. So the answer is 14.83 if you do it literally like this. All right. Always make sure that your CAS is in the correct mode. Now this is 14.8323. So it's not exactly the same. But that is because we were working with this as already a rounded number.
Sir,
Yes.
this 11.87, I think that's wrong. Because 19 times sine of 38.68 is not 11. It's 15.7.
Oh, because my calculator was in radians too. All right. 19 times sine 38 point... No. Sine 38.68. Yep, mate, it's in degrees. It's 11.87. Still right. All right. So, if I do 19 squared minus the answer, I get that. I take the square root of that, and I also get 14.83232. Oh, hey, look. So, I've got two methods that are giving me the same answer. And I've got a third one that's giving me something different. Which one is right and which one is wrong? Yeah, some people's calculators were in radians, yeah. You've got to remember how to swap them backwards and forwards on your calculators. Hey, it's happened. Hey, I thought mine was in radians for a little bit too. It happens. That's why you've always got to be careful to actually pay attention and check to make sure that you're doing the right thing. If on a SAC, I was asking you to do something like this, which, by the way, I'm not. This doesn't show up on a SAC. This is just more of a background introductory task refresher for the trig ratios. Which one of these would you be expected to use to get the most accurate answer? Which one of these is the most accurate answer? The most accurate answer is going to be the one that uses both exact values and doesn't rely on Pythagoras. So technically, none of these are the most accurate answer. Question? So, if I wanted to get the real, truly accurate answer for this question, I'm going to need to go back in time. Ooh. Where did I get that 38.68 from? What was I originally doing?
Just doing normal sine.
Yeah, I was doing a normal sine thing. But what triangle was I using?
5, 8.
5 and an 8. So on my original 5 and 8 triangle, what would that be on the original 5 and 8 triangle? $6.24. How did you get that, Murtaza? Yeah, so you did, that's 8 squared minus 5 squared. So that's 64 minus 25, which is 39. So y should be equal to the square root of 39. So we now have the square root of 39. So it's in a root 39 to 8 ratio. That means we've now worked out that cos of theta is going to be equal to root 39 over 8. That means that instead of writing cos 38.68, we can just write this fraction instead. So y is going to be equal to 19 times root 39 over 8, which is 19 over 8 times root 39 is 14.83187. Oh, look at that over there. Oh. So even though, so now I've got an accurate answer using an exact value. Problem is, how did I get this exact value? Where's the problem? The most accurate answer to my problem of finding A, when I know an angle and a side, and the angle is derived from something else, would be one that I don't use Pythagoras in. But to get that root 39, I had to use Pythagoras. So, how do we find what this angle is? How do we find out what this length is without touching Pythagoras? That is an exact value. All right, that is an angle, that is an exact value. If this angle is theta, what's that angle equal to? So through some logic, you know this is 90, you know this is inverse sine 5 on 8. What is this other angle going to be? How many degrees are inside a triangle?
$180.
180 minus the 90 that we know, minus that. So I can say that beta is equal to 90 minus inverse sine 5 on 8. And that means that the cos of beta is equal to A over 19. Which means that A, the unknown length, is equal to 19 times the cos of beta. And beta is equal to 90 minus inverse sine. So by the end of it, you're going to get an exact answer of 19 times cos bracket 90 minus and what is that answer? No, I made a boo-boo. If you look here, if I'm looking at beta, I'm not looking at cos. I want this. Which means I need to replace cos with sine. Because doing cos of all of that just tells me A11 and what I already knew. So cos of theta. So, yeah. I've balked myself. I've gone too deep. But yes, that. And the answer to that is 14.83187, which is what I got down there. So, this is the sort of logic that your CAS uses when it's trying to solve things exactly. Yeah, so if it was cos still, it would be 11.875, which makes sense because doing cos of beta would just find this length here, which, well, I already worked that out. I need the sine of that. So, if I wanted to do cos of theta, I would really need the sine of beta. Alright, thereby demonstrating a sine theta equals sine of beta equals cos of theta. So the sine of one thing, so in this case, the cos of theta was equal to the sine of beta. Where beta was 90 minus theta. So there's actually a symmetry property in here. Helpful for you to remember. All right, I've talked too much and made too many mistakes, so I'm going to finish talking right now. I'm going a little loopy. That is a very deep dive into something that you probably didn't really need to know because the questions in the book are very easy. Look at all of it in its majesty.